Hello, everyone. I'm your host, Cynthia Wins, welcoming you to another episode of SLB New Energy Conversations. As the world moves towards a sustainable future, technology and innovation are crucial for reducing carbon emissions, enhancing energy efficiency, and ensuring a reliable energy supply. In this episode, we'll explore how these advancements are transforming the energy landscape and what it takes to bring them from concept to reality. Today, we have a special guest, Alan Nelson, Vice President, Technology Development, SLB. Alan has a wealth of experience in developing cutting edge technologies for the energy sector, and he's here to share insights on the future of energy, the role of technology, and the importance of partnerships in driving innovation. Welcome, Alan.
Thank you.
Let's just dive right into the conversation.
Thank you very much.
Absolutely. So glad to have you here.
It's great to be here.
I want to start off. If you elaborate on the role of technology, like addressing all the global challenges, let's just start there.
Oh, great question. I've spent my entire career at the intersection between technology, new business development, and sustainability. And I can say without question, technology is absolutely crucial to solving the world's energy demand and energy production issues, again, worldwide. Um, if you look back over the past couple of hundred years, there's a couple of really notable innovations. The first commercial deployment of the steam engine in 1712, the first oil well in 1859, the first geothermal power plant in 1904. The whole market of energy production and energy consumption is absolutely and fundamentally grounded in technology and innovation. And as you look across the market today, we're still continuing and advancing all of those areas, but we're seeing tremendous opportunity in platforms like carbon capture and carbon sequestration. Geothermal and geoenergy continues to expand and continues to grow. Long duration energy storage to help enable the safe and efficient use of renewables, as well as the production of critical minerals or critical elements, probably a little bit more correctly. But technology is ubiquitous up and down the entire energy value chain. And in order for us to continue to meet society and world demands for energy, we'll absolutely need the latest and greatest technology.
Amazing and complex. So, kind of looking at the complexity of the challenges, how important are partnerships in the energy sector? And then, second to that, how does SLB leverage them to drive that innovation?
Yeah. So for me, again, partnerships are absolutely crucial. If you take a step back and look at the realm of innovation, most people will take one of three perspective when it comes to innovation. The first perspective is I can do everything better, faster, more cost effective myself. There's a second model where innovators will say, I will only partner if I absolutely have to, if I don't have a particular technology or if I don't have a particular skill set. So it's almost a forcing function in a way. Then there's the third camp, which is partnerships are absolutely essential to accelerating and commercializing technology. And for me and for SLB, we very much align with that third camp. Partnerships are critical to not only identify the right technology, but to be able to accelerate the commercialization and deployment of that technology. And for us, we work across the entire partnership ecosystem. We work with and invest in startups. We work with a number of academic institutions. We work across industry. So it's where and when all those partnerships make sense, but we harvest and leverage the entire network. I think one of the key points, though, when it comes to partnerships is not only asking the question, what do you bring to that partnership, but what does the other party bring to that partnership? And I think this is where a lot of companies or organizations get it wrong. They only look at it through one lens. But it's really important to make sure that the partnership benefits both parties and that each one is bringing something unique to that partnership.
And the birthing of innovation.
Correct.
Right there, when we each bring something. So, speaking of innovation, how does SLB's global network of technology centers contribute to this effort?
Yeah, at SLB, we have an extensive network of global technology centers. In fact, we have over 70 centers across 90 countries worldwide. And these centers for us span everything from early stage fundamental research to product development and product prototyping, all the way into advanced manufacturing and commercial deployment, right, for all of these different technologies. And we have a very diverse and a global presence for multiple reasons. One of the reasons is access to diverse talent and skills. Again, kind of going back to that innovation model, it's very easy to think you can do everything in one location. But once you start tapping into that global network and get that diversity of thought and get that diversity experience, you can not only accelerate, but you can actually make those technology solutions so much richer at the end of the day. The other piece of it for us as well is proximity to customers and proximity to markets. Again, if you try to do everything in one location, you lose the nuances of what a customer needs, what a customer demands. And importantly, you don't understand how rapidly markets are changing. And you have to be in those markets with the customers to adapt and to adjust your innovation strategy to ensure you have the right technology commercialized at the right time.
So, as we think about key technologies, what are some of the key technologies that you believe will accelerate in the near future?
Mhm. For me, it is a portfolio-based solution. There's not going to be a single technology or even 2 or 3 technologies that are gonna solve the energy generation and energy consumption challenge worldwide. So it's going to take a portfolio type of approach. One of those technologies for us is geothermal and geoenergy. If you consider today, almost 25% of all the carbon dioxide that's produced is actually generated as a result of building heating. There's a tremendous opportunity to use geothermal energy to offset the other forms of energy that are going into building heating today. If you look out to 2050 and look at the impact of increasing global warming and increasing temperatures, that also means that global or building cooling is going to be equally important. You're seeing extensive or significant increase in global cooling demands, and this too is where geothermal energy can have a significant impact. Carbon capture and storage is another key domain for us. There will be a demand and a place for conventional energy sources, and we need to responsibly offset the CO2 that's generated through the use of those systems. Today, we're deploying carbon capture technology worldwide, but again, there's so much more that we can do from a technology and innovation standpoint. Another area is around, as I mentioned earlier, around critical minerals and critical elements. All of the devices that we use, whether it's smartwatches or phones or EVs, have a high amount of critical minerals and critical elements that are needed to produce those elements and produce those products today. Many of those are not necessarily sustainably produced. We're developing and innovating around technology platforms to do just that, to be able to produce, to extract those minerals, very low energy, very low water usage, and make them as sustainable as possible.
So I understand some of the challenges you're commenting on. So when you look at those challenges, what would you say the biggest challenges you face in developing and then implementing new energy technologies?
I think there's a number of key challenges to be sure, and I think where I would start is the scalability and productization. Many technologies work on very small scale, they'll work in the laboratory, but scaling them up, scaling them out, and actually getting them into manufacturing is oftentimes a very, very difficult challenge. And in fact, for us, we've looked at developing many technologies that work at small scale and decided not to pursue them because we didn't see a pathway to actually scaling them up. Hopefully, some of those challenges are solved in the future, so we continue to watch,
Right.
but certainly scalability and productization is one of the key areas. A second area is around business models. In new energy, this new energy essentially equates to new business development at its core.
Mhm.
And what that means is that the business models are continually changing. What markets want, what customers want, continually evolving. And so you have to be very adaptable and very resilient and very flexible
Mhm.
in terms of what are those products and services that you're developing, getting the right degree of technology at the right price point at the right time to bring that in the market. Another area is around understanding not only what is changing, because in new energy and new business development, we often ask ourselves the question, what's changing in the markets? But for me, it's equally important to ask the question, what is not changing? So that you don't overreact or underreact,
Mhm.
right, to how the markets and how the customers are moving forward. Certainly, regulatory environments are very important. Regulatory environments can help seed technology to provide incentives and tariffs and really accelerate the adoption and give us time to capitalize on the learning rate to get production volumes and get the cost down for many of these things. Another area, though, which is really important is timing. It's not only about having the best technology, the best business model, but if you don't have the right technology at the right time, you're not going to be successful. And being too late is just as bad as being too early. For me, timing is just as important as the technical solution or the innovation that you're trying to bring to market. And it's for a couple of reasons. One, there's a lot of hype when it comes to new technologies today. I'm sure you're like me. You don't open up the newspaper or a web page without seeing some breakthrough that's going to solve the world's energy problems. So having the ability to sort through hype from reality, I think is really important. Again, you don't want to be too early, but you don't want to be too late. So you have to sense check the reality and the timing of some of the adoption of these innovations. Another aspect is customer uncertainty in terms of the timing of adoption, when they're ready to actually scale up. And that goes from a pilot stage all the way through into large scale commercialization. There's another element around timing, and I'll characterize this as infrastructure gaps, or you could say supply chain gaps. For example, if you're able to produce renewable electricity today, but you don't have the grid infrastructure, you don't have the transmission or distribution, such that you're not able to get that electricity from where you're generating it to the point that you're using it, you're not going to see rapid expansion or adoption of that renewable energy deployment, not because the technology isn't good, but simply because you don't have the infrastructure, right, to uplift it and to get it where it needs to be. In technology, we often talk about Moore's Law, right? Moore's Law is kind of ubiquitous when we start talking about the advancement of technology. But for me, really what this comes down to is a different law, and it comes down to Wright's Law. And Wright's Law basically says everything gets better and everything gets less expensive with time. And that's very, very true when it comes to technology. The first product that you produce will inherently be the most expensive. But given the opportunity to produce more of it, i.e., scale it up, given the opportunity to learn about that technology, given the opportunity to learn how to advance the manufacturing of it, the cost and the price point will only come down. And I'll share with you anecdotally, I've been in lithium ion batteries various times in my career. And 30 years ago, we would talk about the price point of lithium ion batteries being $1,000 a kilowatt hour. And today we're less than 50. And if you'd ask the younger Alan whether or not he saw $50 a kilowatt hour 30 years ago, I'd probably say unequivocally, absolutely not. And yet here we are. And that's the power of Wright's Law, the ability to scale and the ability to get costs down.
So, Alan, can you share any success stories or case studies where SLB's technologies have made a significant impact?
There's several that I can share with you. In fact, that we've been able to bring to market even over the past year. Let's start with carbon capture. Today, we're deploying carbon capture worldwide. And in fact, earlier this year, we commissioned, started up, and are now operating the world's first commercial scale carbon capture facility at a cement manufacturing facility in Europe.
Amazing.
First of a kind, tremendous accomplishment by SLB and the entire team. In the geothermal area, we've been at the forefront of geothermal energy production, not measured in years, but for decades. Certainly in the conventional geothermal area. And today, we're very much focused on the next gen geothermal technologies that we call advanced geothermal as well as enhanced geothermal. And this has the potential to unlock even greater geothermal reserves and further expand and open up the geothermal market worldwide, really without limitation. And another example that I'll give you is around the critical minerals space, where last year we successfully commissioned and started up one of the world's first direct lithium extraction facilities for the sustainable production of lithium from brine. This facility allows us to extract lithium in a very energy and efficient way, as well as minimizing water usage. So in a very, very sustainable way, we're able to produce lithium that goes into many different technologies, not only lithium-ion batteries, but many other platforms that really enable the growth and adaptation of the energy markets.
That's amazing. So, looking ahead, how do you envision the energy landscape in the next 10, 20 years?
Yeah, I think there's numerous examples of potential outcomes in terms of how the energy industry is going to evolve. And I stress it as outcomes because there are no certainties in terms of what the future holds for all of us. But again, if you look at the technology slate, there will still certainly be a demand for conventional hydrocarbons. And whether we hit peak oil or peak natural gas in 5 years or 10 years, that can be debated. But I don't think there's any debate that there's still going to be some amount of conventional energy use to be sure. And what that means is that decarbonization, carbon capture, carbon storage are absolutely part of the solution when it comes to clean energy production. Geothermal energy, critical minerals production. Critical minerals are absolutely essential to enable a lot of these different technologies, whether it's energy generation or whether it's energy storage and enablement of renewables. You need all of these different technologies from an ecosystem standpoint in order to address the energy demand and the energy consumption needs moving forward.
We so look forward to seeing how SLB continues to innovate and lead in this space. Alan, thank you so much. Your insights today and your ability to articulate them have just been wonderful. We can't thank you enough.
Thank you very much. It's great to talk to you.
Absolutely. To our listeners, thank you so much for tuning in. Stay tuned for more episodes of SLB New Energy Conversations, where we explore the exciting world of energy innovation.